Hi there, IG Bits welcoming you all subscribers, remote users, watchers, listeners, whoever joined in today's session. For everyone, welcome and happy learning day. Today, we are going to look at different form proper fractions to decompose them into partial fractions by using so far learned 4 rules. Let's see. Okay, today we are not going to solve the problem, but we have to understand the problem, analyze the given problem statement, and identify which rule can be used to split into partial fractions. Okay, that's a learning that we are targeting for today's goal. Without further delay, let's get started. Request to all viewers and listeners, if you have not subscribed the channel, please subscribe our YouTube channel. We have started uploading all learning videos on timely basis. Okay, a great help and great helping hand to extend who are actually in need would be a great the support to the system, right? So we are trying to put our efforts to build the knowledge base, and then I want you all help us to share the knowledge sharing sessions to the your friend circles, extend your support and be a helping hand to build a great knowledge competency teams. Thank you all for your wonderful support so far, whatever you did it, but I would like and wish it to be continue further. Thank you all. So far we have learned 4 rules in splitting proper fraction into partial fraction, right? When a proper fraction has a f of x by g of x, then for looking at the g of x denominator, and then see factors of g of x, whether it is a reduced factors or irreducible factors, repeated factors, or you know repeated irreducible factors. Based out of those scenarios, we found 4 rules which we are going to apply to split given proper fraction into partial fractions, isn't it? In the rule number 1, what we studied is non-repeated reduced factors. We have a factor which is of g of x which is non-repeated. In that case, what should be done in rule number 1 was known to us. In rule number 2, it is similar to rule number 1, but the factors are repeating. Right? So those cases, what you should be done, right? That we know that we have already looked at in the previous class. Whereas in rule number 3 and rule number 4, we spoke about irreducible factors. Means for us it's a difficulty to find out a factors for those polynomial portion, and hence we call them as a irreducible or non-reducible factors. In rule number 3, if it is non-repeated irreducible factor, then we have to apply whatever rule number 3 talk about, right? Ax plus b by that polynomial. In rule number 4, if at all irreducible factor is in repeated nature, then we have to apply rule number 4, and hence these 4 rules we are using in splitting proper fraction into partial fractions, isn't it? Let's look at this problem statement. Resolve given fraction into partial fraction. What is the thumb rule? As a checkpoints, right? First checkpoint, what we identified, check whether g of x and given fraction is a proper fraction. Proper fraction. We all know the definition of proper fraction, right? The degree of numerator is always less than the degree of the denominator. In the degree, in the g of function, denominator function, if you see x into x is x squared, the degree is 2, isn't it? And the numerator degree is 1. So 1 is less than 2, and hence this is a proper fraction, right? Second thing, what rule we have to apply? Look at the g of function carefully. So these are two terms that I'm seeing, two factors, right? X minus 1, x minus 2. These factors are appears once, right? One occurrences of each factor. X minus 1 is one time appearing in your g of x function. X minus 2 appears once in your g of x, right? So in the denominator you are seeing these two factors appears at once, and hence this should be rule number 1 of partial fraction. So according to rule number 1, how do you write it? X by x minus 1 factors x minus 2 can be written as, what is the rule number 1? A by x minus 1 plus b by x minus 2, right? And then you got this point. Now what you have to do, if you can take the LCM x minus 1 and x minus 2, right? This is an LCM, and then all you have to do is like a cross multiply, right? A into x minus 2 plus b into x minus 1, and then by using elimination or substitution method you can determine constants a and b, right? And then plug in those values into the original form, decomposition form, okay, which is what we say a partial fraction for given improper fraction. So you got the point. You are able to understand. First thing is like how to identify a proper fraction, then you have to figure out like which rule can be applied, and then split the function into partial fraction using that rule, okay, whether it is either it is a 1 2 3 4, whichever it is, okay, relevance for your given problem statement. Currently this is what the statement, okay. I'm not going to solve the problem rest, because this class is only to identify what rule can be applied and how we are going to decompose given fraction, proper fraction, into partial fraction, okay. Okay, let's look at this problem statement. Resolve x squared by x minus 1 times x minus 2 into partial fractions. First, what you have to check, whether it is a proper fraction or not. How do you calculate a proper fraction? Again, same rule we have to apply. Proper fraction, degree of numerator should be lesser than degree of denominator. In our case, numerator is degree is 2, denominator is also 2, right? Degree of numerator is 2, and then degree of denominator is also 2. So this is not a proper fraction, isn't it? To get the proper fraction, you have to represent it, right? You have to divide given function to make it proper fraction. The one way to write this function, x squared divided by x minus 1 times x minus 2, can be written as 1 plus, right, a by x minus 1 plus b by x minus 2, right? This is an additional step that you have to follow, right? 1 plus, then obviously the degree will be reduced, and then you have to find out, as a previous step, a by x minus 1, b by x by 2. So now we know this, how to solve this problem. X square equal to 1 times rational, right? X minus 1 times x minus 2 plus a times x minus 2, this multiply, and then b times x minus 1, right? You have to, now you can apply, either you can using substituting x into some arbitrary value to nullify given terms, or you can compare coefficients either side of this equation, right, to determine constants a and b. Once you calculate the a and b, you can plug in back to this equation, then this would be your partial fraction for a given proper fraction. In this case, this is not a proper fraction, but you can convert it into proper fraction, okay. You got the point? Very nice. Look at this one. The given problem statement is x by x minus 1 whole square. So x minus 1 is a reduced factor. Correct now? This is already reduced factor. Then this reduced factor appears twice, repeated, isn't it? This is repeated. So reduced factor repeated. What rule that you have to apply? We have to apply rule number 2. And then make a note, this is a proper fraction. Why proper fraction? Degree of numerator is lesser than degree of denominator, right? That's right. So now, what is the rule number 1 says? You have to say a by x minus 1 plus b by x minus 1 whole square. Then this is a reduced form. I mean, this is a partial fraction, right? For a given proper fraction. Once we have that, next is so simple. X equal to a times x minus 1 plus b. Then you can apply, either putting some value, arbitrary value for x to nullify, to eliminate one of the constant, or you can compare either side of the equation, the coefficient of the given constants, x terms, to find out a and b values and plug in those into this partial fraction. Okay, any question? That's good. This is very straightforward, right? Anyway, if you put like x equal 0, put x equal to 1, what happens? This becomes 0 and hence b would be 1, isn't it? The next one, let's compare both sides, right? So compare, okay, coefficients of what? A, x. Then what happened? This is 1 equal to a, isn't it? Then the final answer would be 1 by x minus 1 plus b value is also 1 by x minus 1 whole square. Okay, this is the partial fraction for given proper fraction. Clear? Okay, next problem. Resolve x square by 2x minus 1 times x minus 1 whole square into partial fraction. The first thing is, like, is it a proper fraction? Right? Degree of numerator is 2. Degree of the denominator, this 1, this is x square 3. So 2 is less than 3 and hence this is a proper fraction. So rule number 1 is done. So you validated this is a proper fraction. You don't need to split anything. Okay, what next you have to do? You have to find out which rule that I can apply. Do you see the g of x function? 2x minus 1 is already a reduced function. You don't need to reduce further. Second thing, x minus 1, this is also reduced function, right? Because you can get x value directly. However, this is a repeated one, right? So sounds to me we have to apply rule number 1 and rule number 2. So both combinations to resolve this problem statement, isn't it? So the first rule number 1, a by 2x minus 1, agree? Plus, then you have to see x minus 1 square, it's a repeated, right? So we need to get it 2 partial fractions for this one. So you can apply one constant b by x minus 1 plus c by x minus 1 whole square. Clear? So then you have to use like your own method to find out a, b, c and plug in back to them to get the partial fraction for a given proper fraction. Any doubt? Good. So let's try out x by x square minus 1 into partial fractions. The first thumb rule is find out whether it is a proper fraction or not. Yes, I have a numerator degree is 1, denominator is 2, and hence this is a proper fraction. And then which rule that I apply? If you can really observe given problem statement, this is x square minus 1, right? G of x1 is given, g of x is x square minus 1. This sounds to be like a square minus b square formula, right? A square minus b square formula. How do you get it? A plus b times a minus b. If you can apply the same here, this is x minus 1 and x minus 2. X minus 1, x plus 1 are the factors for x square minus 1 polynomial. Okay, so I can rewrite this back x divided by, right, x minus 1 x plus 1. Okay, so if you see, these are the reduced factors, and hence I can apply rule number 1. What is the rule number 1 is talks about? I can say a by x minus 1 plus b by x plus 1, right, for x by x minus 1 into x minus 2. Then you can find out a and b constants, then plug in back, and hence this would be your final partial fraction once you find out a and b, isn't it? So are you confident to identify how to apply the so far learned 4 rules to resolve given proper fraction into partial fraction? Okay, yeah, good to hear. Let's move on to next problem statement. See this one. Resolve x cube plus x square plus 1 divided by x minus 1 times x cube minus 1. My god, so this is a little bigger problem. X cube plus x square plus 1 divided by x minus 1 x cube minus 1. How do you write this one? X cube plus x square plus 1 divided by, this is x minus 1, isn't it? This one a cube minus b cube, right, can be written as a minus b plus x square plus x plus 1, isn't it? That's what you can write. So a cube minus b cube, how do you write it? A minus b times a square plus ab plus b square. Okay, so this is what it is. If we can simplify further, this one x cube plus x square plus 1 divided by x minus 1 times x minus 1, this is becomes x minus 1 whole square, right, and x square plus x plus 1. This is the reduced factor but appears twice, and hence this portion is, for this portion we can apply rule number 2. Look at this one. This is irreducible factor. We cannot actually factorize this easily, because if you can calculate a discriminant for this polynomial, you will get a b square minus 4ac is less than 0, imaginary values. So this is irreducible factor, and hence we have to apply rule number 3. So combination of rule number 2 and rule number 3 would be a partial fraction for this given problem. Is it not easy? So how do you rewrite this one? For this, what you have to do, a by x minus 1 plus b by x minus 1 whole square, because x minus 1 is repeated reduced factor. So that is a rule number 1. For this one, this is irreducible non-repeated factor of g of x, and hence we have to use cx plus d rule, right? Cx plus d divided by given problem x square plus x plus 1. Once you split this one, then all you have to do is like a finding a b c d and plug in them back. to get the final partial fraction for a given problem statement, right? Okay, you got the point? Yes. So thumb rule is simple. First you have to find out whether it is a proper fraction or not. Then you have to find out like what rules that we can apply to split, meaning decompose the given fraction into partial fraction. Once you are able to figure out, then our job is to find out a constants and then plug in them back once you have the values. That's it. That's your final answer. Next problem statement. What is given here? 2x square plus 3x plus 4 divided by x square plus 4 whole square. By looking at this, you see this is irreducible factor. You cannot reduce it because it is not a x, right? It's x square plus 4, but I cannot factorize it easily. And hence what I can use, I can immediately reminds my rule number 3. However, this irreducible factor repeats twice. So then the rule number 3 becomes rule number 4. So all we have to apply rule number 4 here, isn't it? So accordingly, rule number 4 means I have to start with ax plus b divided by x square plus 4 plus cx plus d divided by x square plus 4 whole square, right? Sounds like a your repeated reduced factor, but in our case here this is like irreducible, and hence instead of using like a single constant, now you are telling ax plus b term as a numerator to resolve repeated irreducible factors of gx. Okay, once we have this format, then you are just finding constants a b c d and plug in them back to get the final partial fraction. Understood? Yeah, it makes sense. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. Thank you all once again. Stay tuned to next session. If you have any doubts, leave in the comment section. Okay, I will look into it then respond back to you all. Okay. Okay, have a good day. See you again. Bye bye.